Good morning, students. Welcome you all for next generation learning. Today we are going to see the subject physics, class 9. Chapter number 10, Gravitation. This chapter contains 7 topics: 10.1 Gravitation, 10.2 Free Fall, 10.3 Mass, 10.4 Weight, 10.5 Thrust and Pressure, 10.6 Archimedes Principle, 10.7 Relative Density. Today's topic 10.2 Free Fall. First, you have to understand the meaning of the free fall by performing an activity. For doing this activity, you have to take small stone and throw upwards. If you throw the stone upwards, what would happen? It reaches a certain height and then start to falling down. So we have learned that the earth attracts object towards it, and see in the second diagram the ball is falling towards the earth. So the earth attracts this ball because due to the gravitational force between earth and ball. Whenever object fall towards under this force alone, the gravitational force alone, we say that this object are in free fall. Is there any change in velocity of falling object? See here, you know that what is meant by velocity. If the object is moving in this direction, suddenly it changed the direction, here the velocity will occur. So in a free fall action, is there any change in velocity of falling object? No, because the ball falling only in one direction. While falling, there is no change in the direction of motion of the object. So there is no change in direction of motion. But due to the earth attraction, there will be change in the magnitude of the velocity. See here, when the ball falls towards the earth, there is no change in direction, but the magnitude of the ball will change. So the magnitude of the velocity will change. Any change in velocity involves occur. If a velocity change means the acceleration occurred. Whenever an object falls towards the earth, an acceleration is involved. Why the acceleration is involved? The direction of the object is not changed, but the magnitude of the velocity is changed. When the magnitude of the velocity is changed, automatically the acceleration term involved. So this type of acceleration is called acceleration due to gravity. Why? Because due to the gravitational force alone, this object accelerated. So therefore, this acceleration is called the acceleration due to the gravitational force of the earth. So it is called acceleration due to gravity. It is represented by the letter small letter g, and the unit of this is meter per second square. In chapter number 8, we learned that A equal to acceleration. But in a gravitational, due to the gravitational force, the object will accelerated means That acceleration is called acceleration due to gravity, and it is represented by the letter G. In Newton's second law of motion, we know that the force equal to mass into acceleration. The product of mass into acceleration gives the force. Here the mass of the stone, this is a stone, the mass of this stone is m. We already know that the acceleration involved, so the acceleration involved is here g. Therefore the force, the gravitational force, we can write it m into g, mass into acceleration due to gravity. So there are the two formula for F. One is m into a, that is mass into acceleration, m into g, mass into acceleration due to gravity. Sorry, here some mistakes. In gravitational force, you know that F equal to g capital M into small m by d squared. This is a gravitational force between two masses, m, capital M and small m. And in previous one we know that F equal to m into g. See, in these two equations, the left side is same but the right sides are different. So we can equate these two equations. So how you have to write? mg equal to g capital M into small m by d square. And you have to cancel m and m. So the remaining thing g equal to, here it was missed, g equal to g m by d squared. So here capital M is nothing but the mass of the earth, and d is the distance between the object and the earth. Maybe this is the earth, the object is falling towards the earth, so this is the distance, and this, the capital M represent mass of the earth. So the acceleration due to gravity G equal to small letter g equal to capital letter G m by d square, where m is the mass of the earth, d is the distance between the object and the earth. Let an object be on or near the surface of the earth. The distance d in equation will be equal to r, the radius of the earth, for object or on near the surface. Please understand this concept. This is a earth. The object is placed the surface of the earth. So the distance between the object to earth is equal to r. See the difference between these two. When the object is placed here, the distance between the object to ball is, we can take as d. When the object is placed near or surface of the earth, this d is equal to the radius of the earth. So in small letter g we know that g equal to g m by r square, d square. For when the object is placed near the surface of the earth, this d squared is equal to r squared. So g equal to capital G m by r square when the object is placed on the surface or near to the earth surface. See, this is a earth. This is not a perfect sphere. You know that this is a pole and this is equator. So just I draw the line. So the earth is not a perfect sphere. The radius of the earth increases from the poles to the equator. So this is a radius of the earth, but comparing to the poles, then equator, if you move to the equator, the radius of the earth is increases. So the value of G becomes greater at the poles and smaller at the equators. How we can say that the acceleration due to gravity, that is G is increases in the pole than equator. See, you have to take this equation G equal to G m by r square. Here the capital G is the gravitational constant. The m is the mass of the earth. So the gravitational constant and the mass of the earth is always constant. And see the radius of the earth. Now you can compare. The acceleration due to gravity only depends on the radius of the earth. It does not depends on the mass of the earth. So small letter g, the acceleration due to gravity is inversely proportional to 1 by r squared. And take here in a earth, the radius of the pole is less. So the radius of the pole less means the acceleration due to gravity is more. When r value is less, g value is more. If you take an equator, the radius of the earth is more. So the acceleration gravity is less at the equator because the acceleration due to gravity is inversely proportional to the r squared. Please note that the value of acceleration due to gravity g is not constant at all the places on the surface of the earth. So the g value is not same at all the point. It will change according to the place. Why it is not same at all the point? Because the radius of the earth at the pole is minimum, so the value of g is maximum at pole. Again, if the radius of the earth maximum at the equator, so the g value is minimum. Do you understand this concept? The g value is not constant at all the point. Why? Because the radius of the earth is less at the poles, more at the equators. So the acceleration due to gravity is more at the poles, maximum at the poles, minimum at the equator. And this is a formula here, G equal to capital G m by r square. Since the acceleration due to gravity does not depend on the mass of the body, all the bodies fall with the same acceleration towards the surface of the earth. And this is a very important point. Please listen very carefully. G equal to capital G in capital M by r square. In force formula, we can know that capital G m into m by r square. Here the small letter g represent the object and the capital letter G is the mass of the earth. For in this formula there is no mass of the object. The capital M represent mass of the earth. So in acceleration due to gravity does not depends on the mass of the body. So all the bodies accelerated towards the surface of the earth in the same way. This is the object. the small stone and this is a big stone. It has mass 5 kilogram. This has mass 1 kilogram. But the acceleration due to gravity, the g, does not depends on the mass of the object. So both the objects are accelerated at the same rate towards the earth. I hope you understood this concept. So how to calculate the value of the g? You have to take this formula. Small letter g equal to capital letter G m by r squared, where the capital letter G value is 6.7 into 10 power minus 11 Newton meter square by kilogram square. The mass of the earth, that is also constant, 6 into 10 power 24 kilogram. The mass of the earth also constant, 6.4 into 10 power 6 meter. Now you have to put this constant values in this equation. So small letter g equal to 6.7 into 10 power minus 11 into 6 into 10 power 24 by 6.4 into 10 power 6 whole square. Now see the power 10 power minus 11 into 10 power 24. In here 10 power 6 into 2 10 power 12. So when the 10 power 12 come to up 10 power minus 11 into 10 power minus 12 into 10 power 24. So 10 power minus 11 in minus 12, 23 into 10 power 24. So if you subtract these two, we can get 10 power 1. The power we can get 10 power 1. So if you multiply 6.7 into 6 by 6.4 into 6.4, we can get the final value 9.8 meter per second squared. So the acceleration due to the gravity value is 9.8 meter per second squared. This is a constant value because in this equation g equal to capital G m by r square. Here g also constant, m also constant, r also constant. So when we substitute the constant values in the equation, we get the constant value. So g equal to 9.8 meter per second square. This is the value of the acceleration due to gravity. So motion of object under the influence of gravitational force of the earth. So what is meant by the motion of the object under the influence of gravitational force of the earth? You take this is a earth and this is a object. Due to the gravitational force of attraction, the object is accelerated towards the earth. Okay. Let us do an activity to understand whether all objects, hollow or solid, big or small, will fall from height at the same rate. This is a very important point. You know that hollow or solid. You have to take a hollow ball and stone. Here the stone is a solid and this is a hollow ball. When we drop these two objects from some height, you know that the solid object reach at first, the hollow object reach at second. And if you take big or small, you have to take the big ball of 10 kilogram and a small ball of 1 kilogram. We drop from some height. Which one reach the ground at first? we know that the 10 kilogram ball reached the first, the 1 kilogram ball reached second. But due to the gravitational force, the object hollow or solid, big or small, they fall from some height at the same rate. So both the object are reached at same time to the ground. So see this example. A big stone will fall with same acceleration as a small stone because the acceleration due to gravity of the earth act on them during their free fall does not depend on the mass. We learn that G equal to capital G m by r square. Here the capital M is the mass of the earth, that is not the mass of the object. So the acceleration due to gravity does not depends on the mass of the body. So whatever may be the mass of the object, all the objects are accelerated at the same rate. That means they accelerated at 9.8 meter per second. The 10 kilogram object also accelerated at 9.8 meter per second square, and 1 kilogram stone also accelerated at 9.8 meter per second square, because the acceleration due to gravity is not depends on the mass of the object. See this point. Both the stones are acted upon by the same acceleration 9.8 meter per second square. In other words, if a big stone and a small stone are dropped from the roof of a house simultaneously, they will reach the ground at the same time. For here I took feather and stone. You know that the feather is a lightweight material and stone is a solid material. When we drop for doing this activity, you have to take a glass jar, and when we drop these two objects inside the glass jar, the stone will reach at the first, the feather will reach at the second. For in this glass jar, the air is filled. Using the vacuum pump, I evacuated the air from this glass jar. So here there is no air. Now if I drop these two objects simultaneously, both the objects reach at the ground at the same time. So if there is no air resistance, means the object reached at the ground at the same time. So all the objects are accelerated only 9 meter per second square. So the equations of motion for freely falling object. Since the freely falling object with uniformly accelerated motions, the three equations of motion derived earlier for bodies under uniform acceleration can be applied to the motion. In chapter number 8, we learned the three equations of motion. V equal to u plus at, S equal to ut plus half at square, and v squared equal to u square plus 2as. These three equations of motion we learnt in the chapter number 8, motion. For the same three equations of motion we are going to apply for the free fall object. So for freely falling bodies, the acceleration due to gravity G is, so we replace the acceleration A of the equation by G, and the vertical distance of the freely falling body is known as height. So h we replace distance in our equations by the height h. See, this is a general equations of motion. Here v is the final velocity, u is initial velocity, A is acceleration, t is time. S is distance. That means if the object is moving along a straight line, initially it has the velocity u, finally it has velocity v. And it traveled some distance s in the time t. When it is traveling from point A to B, the acceleration A will occur. A will involves. The same equations we have to apply for free fall object. So when the object are free fall, initially it has velocity u, final velocity v. Here the distance is vertical, so in the distance we can take as h, not s. This acceleration is a normal acceleration. When the object free fall, the acceleration is called acceleration due to gravity g, and the time we can take as a time. So this is for normal object, this is for free fall object. So see in this equation, v equal to u plus at. Instead of a, you have to write v equal to u plus gt. In second equation, s equal to ut plus half at square. Instead of s, you have to write h, and instead of a, you have to write g. In third equation, v squared equal to u square plus 2as. Instead of s, you have to write h, and instead of a, you have to write g. See, v squared equal to u square plus 2gh. So these are the three equations of motion for free fall object. V equal to u plus gt, the first equation. H equal to ut plus half gt square, second equation. And v squared equal to u square plus 2gh, that is a third equation. So the next class we will see the numericals related to the equations of motion for freely falling bodies. Thank you for watching. If you have any doubt regarding these topics, you can ask through Teachment. You have to take your science book and open the chapter number 10, Gravitation. Yeah. Today I taught the topic 10.2 free fall, and here I explained the activity. Take a stone, throw it upward. It reaches a certain height and then start to fall down. So this is the diagram, and I explained that what is meant by acceleration due to gravity, and this is a unit of acceleration due to gravity. And we derived the equation g equal to small letter g equal to capital letter G m by d square, and they given the m is mass of the earth and d is the distance between the object and the earth. So when the object is on near the surface of the earth, the d is equal to r squared. So small letter g equal to capital letter G m by capital letter r squared. And here see, the earth is not a perfect sphere. The radius is less at the poles, maximum at the equators. And we calculated the value of the g. The value of the g is 9.8 meter per second squared. The next one, the motion of an object under the influence of gravitational force of the earth. In this activity, they took paper and stone. In a video I explained that feather and stone. The paper and feather are lightweight material. The stone is a solid material. But both the material reach at the ground at the same rate when there is no air resistance. And these are the three equations of motion. So the next class we will see the numericals related to the equations of motion of free fall object. Thank you for watching.